Hello, everyone. I'm going to give you a brief on AML, trying to demystify what it is and look at a few examples. So here we go. What is AI? So AI is basically a constitution of various other components like machine learning, deep learning, NLP, computer vision, robotics, expert systems, reinforcement, generative models. Generative models are what you would call as mid-journey chat GPT, which are able to generate new data based on what they have learned and based on what you're asking. And so let's look at some more. So what are types of AI? So there are like basically three types: weak AI, strong, and ASI. Strong AI, we are not still in the strong AI realm, even though it feels like the AI is pretty advanced. ASI, we have a long way off. So what we have currently is weak AI. So even if you ask ChatGPT, are you a weak AI or strong AI, it basically answers this in the form of weak AI or a narrow AI. Basically, it's just going to tell you what it has been trained on, and it can generate. It doesn't have much intelligence. So here are the things: AI, ML, and DL. So AI is the ability of machine to replicate. ML is it allows you to learn, so you can pass it, you can train it, and that's making deep learning is the networks for advanced tasks and neural learning and look at complex patterns. So that's what these three things mean. Let's look at NLP. So what is NLP? NLP is natural language processing, is part of AI, computational linguistics, or more of an academic realm. But with the advent of OpenAI, ChatGPT, it is more prevalent. Now, NLP has got two parts to it: the NLU, the natural language understanding, and NLG, which is natural language generation. Now, NLU is part of, like, if you have unstructured data like voice, if you're speaking to it, or if you're giving handwritten text to the AI, and then it's able to convert into structured. So that's what it's trying to understand in natural language and converting into structured data. And NLG is its counterpart. It basically takes the structured data and converts it into a natural language output which humans we can understand. Now let's look at the generative AI, LLM, and foundational. Generative AI is what ChatGPT is. You can create text or mid-journey. You can create pictures, images, and music. So this is they are able to generate content. So that's why they're generating AI. LLM is large language models. Is basically the L stands for large. Is the large kind of text from web, from books that the model has been trained on, and it's mostly used for text. And that's what the L is, a large language model. Foundational model are the basic models which are used to build on more advanced model like the GPT, and GPT is a foundation for GPT-2 and 3. Difference between AI, LLM, and foundation. So the the generative, as I said, basically creates new content. LLM is a language model. It has large text, as we talked about. Foundation is that foundation to the advanced models. Primary function, generate new data. LLM is process and generate human-like text. And so basic examples, GPT-3 Midjourney. Midjourney we use it for text. GPT-3 as a chatbot. Chat GPT is Chat GPT is LLM has been trained on a huge corpus of text data. Foundational model, these are foundational models. Training data is diverse text has been trained on images, audio. LLM is basically text corpora from books, articles, sites. Application, as I said, is like for Midjourney is art creation, composition. LLM Chat GPT is more the text, and foundation are for custom transfer learnings that you can build. Let's look at some examples of a model like predicting house prices, right? So this is what a model is. So this is a model which uses linear regression. So this is the algorithm which is going to be powering this model. So objective is to predict the house of a price, predict the house based on its price, and data is going to be the data set of house sizes where you can get it from Zillow or you can get it from somewhere else. Is basically we are going to look at two things: the square feet and the corresponding prices. This will be a linear regression, so that means it's a straight line. So step, collect data, scrape it or get it from somewhere, get it from the government. Train the model, we use the data to train it, and this is going to be a linear relationship between house size and prices. Once it has been trained, we can make a prediction. And the prediction is just a math representation of a straight line, y is equal to x plus b. Y is the predicted, m is the slope of the line. And this is standard you would have studied in high school. And b is the intercept, the price where the size is zero. Y-intercept price when the size is zero. So you can look at the thing at M is equal to 200 and B is equal to 50,000 for a house of 1,500 square feet. So we can predict it with the slope being 200 and that is 750 to 350,000. So this is what we can predict, and this is what you can train a model on. You pass in the inputs, the square feet, and it should be able to give you the price. Another example of model is the email spam detection here. The algorithm uses logistic regression. So it can tell whether spam is not based on certain characteristics, keywords, whether the email it contains links. So model logistic. So what we do here is we collect data on emails. There is a huge email corpus on the open source domain where you can get that and that you can train the model and train the model based on the logistic regressions and it can be trained whether the email is being spam or not. Then once you have trained the model can predict the mathematical representation is this equation. And this is the P is the probability the email is spam, and these are the features of the email, and these are the coefficients during the training. And then suppose this so when you're going to feed it for the word free and for the presence of a link, so you can substitute the values in here. It comes to 0.55. So they just mean that is a 55% chance that the email is spam. And pass fail. So pass fail is again a model. It uses classification and regression tasks. Uh, it uses classification regression algorithm here. The objective is whether a student pass or fail based on student study hours and attendance. So the data set, this is what you would gather it from a college, university, or wherever you are at, and get these values in, and you're going to collect the data, if the student hours and attendance, and what their final result was. So these three attributes. This is the final result. You're going to get it when you're going to apply to it, but this has to be trained on so the model understands the relationship between hours and attendance. So once you've trained it then we can put this model live and then it can you feed it the numbers and it's going to provide you what would be a pass fail decision. So it's like a binary. So it splits so the example decision tree would be attendance given 75%, yes. If the study of 10 is yes, it's pass, no it's fail, otherwise if this is no it's fail. So this is a binary tree. The answer would be either yes or no. So example calculation, you pass it with 80% attendance and 12% will take this step, attendance greater than 75, it's true. So this is the decision tree that we have kept it, like these are the parameters above 75, and if it is more than 10, then it's yes, it's pass, otherwise it's fail. So you pass it in and then you get the result of pass. And um, so this is an example of a model again. So the another way to classify the emails is like using the name base. Earlier we used a holistic reasoning model. Here we are using a name based model. So it will, based on the content of the email, the requirement is still the same, whether it's based on whether it is a content and it has a link or not, a link along with the labels. So we're going to collect the data from a corpus somewhere, then train it using the name base, and the model will give the class is spam or not spam. So this is the algorithm, and you give it the features, PAB probability of class, probability of BNA, probability of the prior probability. So apply all of these, put this in the equation, and this is the example. Like if the quote contains free and it contains a link, and So probability of spam and phase 0.8. So you apply it out. So you can point to phase is reliability high probability that the email is spam. So these are good examples, like how you take the algorithms and you apply it and you use it in a model, and it has a real world significance. What is NLP processing pipeline? So this is how the flow is, so how your model gets created. So text processing, we get the clean. We take the data from its raw format. We clean it and prepare it by tokenizing it, lowercasing it, removing punctuation, stop words, stemming, and lemmatization. Lemmatization is basically the base of that word. The feature extraction. We take that and we convert the numeric. We use the algorithm bag of words or the TDAF or word embeddings, and we convert the text into its numerical representation. Once that's done, we train the machine learning model on the process data. And then after that, we apply additional analysis, NER, sentiment analysis, or dependency parsing. Once this is all done, then the model is trained and it's ready. And we take the model, the trained model, and then we put it out there. We can host the models. That is another topic. How you can host the models, how you can deploy it and put it on API so that you can use it with your application. And so this pipeline will help to transform the hard text into valuable insights, and it will give you the NLP application. So another thing, what is the difference between pre-trained, fine-tuned models and RAG? So pre-trained models are models trained on large sets, and they serve as the foundation, and fine-tuned are which has been trained on a smaller, very specific set. So that is different between them. And RAG is basically between RAG and the fine-tuned models, right? So RAG is basically we are dynamically retrieving and we are so this is no training involved here. You're dynamically providing the input, and it's just a real-time input, and you get accurate and contextually relevant responses. Fine-tune a pre-trained model on performance on a very specific set. So these are the two things. And RAG is in use to get very up-to-date responses where your input may change, and then you can constantly provide the new input, and then you should be able to get the up-to-date responses on that. So I hope this was useful, and please comment and like, and if you have any questions, feel free to ask. Thank you.